History of Civil Engineering and Architecture. Civil engineering is one of the oldest branches of engineering. Not only do civil engineers design systems that interact with each other, but they are also concerned with the environment's well-being. The term civil was added to separate these licensed professionals from other types of engineers that work in the military, electrical, or mechanical projects. Architects are licensed professionals who design commercial and residential structures that are used by humans. Times, architects and builders were one and the same. Engineering was a huge part of the architect's or builder's role, especially with the large construction projects such as the pyramids, like the Parthenon, the Appian Way, which was an ancient Roman road, bridges and aqueducts, and the Great Wall of China. Until modern times, there was no clear distinction between civil engineering and architecture, and the terms were used interchangeably. However, in the 18th century, the term civil engineer became to be used to distinguish military engineers. Architecture was born when people began to live in constructed dwellings and within communities. Caves were last used as habitats around 8000 BC. Early engineering was centered around food, the development of tools and ways to increase the efficiency of farming and hunting were documented. First in cave paintings and later in Egyptian hieroglyphics. The history of civil engineering and architecture projects is regional in nature. The development of building design and construction on an African grassland differs greatly from the building design and the construction in Alaska or in the mountains of Peru. A major reason for differences in the development of construction techniques is the availability of local resources. Although it is possible to import materials from great distances, the historic reality is that people often used what was easily available to them when constructing buildings. This influenced architectural style and a selection of structural elements. For example, sun-dried bricks can support loads in a dry climate, but will disintegrate in wet climates. Current-day Iraq consists mostly of alluvial plain. No stone, and wood is scarce. Sun-dried bricks, clay-rich soil mixed with straw, was used as early as the 14th millennium BC. The ruins of the former city of Babylon illustrate how they used mud bricks. Greece consists almost entirely of limestone and has many sources of marble. The finest source of marble comes from Mount Pitilus, where marble was used to build the Parthenon. The pre-Columbian Inca site of Machu Picchu sits on a mountain range in Peru. The central buildings of Machu Picchu use the classic architectural style of dry stone walls in which blocks and stones are cut to fit together tightly without mortar. Because of their durability, examples of stone and brick buildings from past civilizations do exist. However, few examples of ancient buildings exist where there are less durable materials, such as wood and grass. In China and in Japan, most ancient buildings were constructed of wood, except for the tile roofs. Because wood tends to deteriorate over time, few examples of ancient Chinese buildings exist. However, the Chinese have long standardized uniform features of structures through manuals and drawings that were passed on down through the generations. Therefore, we can determine that Chinese architecture changed little over thousands of years. Vernacular architecture is a term used to categorize methods of construction which use locally available resources and traditions to address local needs. It is often viewed as crude and unrefined. So that basically means like raw, like rough materials. But many modern architects have claimed inspiration from vernacular architecture. So here you can see in probably in Alaska or northern Canada, an igloo, which is an Inuit. Inuit is the native people of Alaska and North America. And that is obviously an igloo made of ice and snow. Over here we have an African hut that was built in Cameroon, and you can see it's built with mud and straw and probably some sticks or some type of wood. This is an Apache Wikia built out of brush, grass, and reed. And on the right, this is a traditional Nepalese house built with stone and clay. This is an example of a rondavel or banda. It's built in South Africa, and it's built probably mostly of mud and straw, as well as possibly some types of clay, depending on the soils. The earliest known structures were pyramids. Pyramids in Egypt were built as monuments to house the tombs of pharaohs. The earliest known architect was Imhotep, Imhotep, Imhotep of Egypt. He was known for creating the first step pyramids. The pyramid was a solid structure, but many early buildings were bearing wall types. Bearing walls are solid walls that provide support to each other and the roof. The building next to the pyramid in the right image illustrates a bearing wall system. So here you can see these are your walls, and then you've got a structure going across the top. They're load-bearing walls. That means they're carrying the weight to the ground of the actual building. Egyptians were not the only ones that built pyramids. In the Americas, there were pyramids that were built for religious ceremonies and science experiments. This step pyramid in Yucatan, Mexico, was built for astronomical purposes. Many modern pyramids exist, including the pyramid in the courtyard of the Louvre Museum in Paris. Or this other picture from Las Vegas, which is outside of one of their hotels. Modern buildings are concerned with aesthetics as well as functionality. Aesthetics is the quality of an object that deals with art, beauty, and taste. The Parthenon was built to house the statue of Athena, Greek goddess of war. Like other temples of its day, it was designed to be seen from the outside only. The Parthenon is an example of a post and lintel construction. Horizontal beams placed across vertical posts. This form of construction came about due to an early problem in architecture. How can the door and the window openings be provided in bearing walls without sacrificing support? Post and lintel construction is an example of the early frame system. The columns of the Parthenon are placed closely spaced because it is made of stone, which has little tensile capacity, meaning it's not able to bend a lot. Greek temples showed the change from wide columns to more slender columns. Supporting large openings was a major problem in early design of structures. Although very strong in compression, stone is weak in tension and cannot support weight from a structure across large openings. So remember, compression is a push, so compression is pushing against it, and tension is a pull. The Romans developed the arch to overcome the limitations of the post and lintel system. The arch is a curved structure spanning an opening, designed to support the vertical load primarily by axial compression. So axial compression is where it pushes in from the sides. Because they were made from smaller and lighter blocks of stone, they were easier to put up. Blocks are placed in a curved formation in such a way that they give each other support. The wedge-shaped units in an arch are called the voussoir. The keystone is the voussoir at the crown of the arch, serving to lock all of the others in place. The arch is often used in the construction of bridges, tunnels, sewers, and palaces. So this right here is the keystone. These are voussoirs here. If you know any history, Pennsylvania is actually called the Keystone State, and it's because it held the North and the South together during the Revolutionary War. The development of the arch led to the development of a vault, which is a series of arches that form continuous arched covering. When two of these vaults intersect, a cross vault is created. So this is just a plain vault here, and then this one's a cross vault. Another name for a cross vault is a groin vault. Vaults allow for the construction of bridges, walkways, and other passages. Another form that developed from the arch was the dome. A dome is an arrangement of several arches whose base forms a circle, and the tops meet at the center. The Pantheon is an example of an arch and dome system. It is the oldest standing dome structure in Rome. Two amazing aspects of the Pantheon have to do with the materials used to create it. The Pantheon's concrete was a mixture of volcanic ash, lime, and some amount of water. The mixture was packed, not poured into place. Originally known as the Flavian Amphitheater, this arch and dome system is the largest ever built in the Roman Empire. It is considered by many to be one of the greatest works of Roman architecture and engineering. Modern sports arenas are styled after the Colosseum, so named probably due to the colossal statue of Emperor Nero, which was standing nearby. The Great Wall of China is one of the most ambitious construction projects the world has ever seen. It spans 4,500 miles. Construction spanned from the 5th century BC to 16th century AD, which is 2,100 years. Just imagine that, 2,100 years. Like, if they started building it at the time of Jesus, we would still be building it now. The wall as seen today is mostly constructed during the Ming Dynasty of stone and bricks. The need for dependable water supply for domestic and agricultural purposes led to the construction of dams, canals, and aqueducts. This usually involved conducting the water over long distances. The engineering involved constructing the massive dams and solving problems associated with getting water to flow to its destination. Since water flows downhill, a combination of canals, tunnels, and aqueducts were required. The Roman aqueducts were built between 300 BC and 200 AD. These provided Rome with the ample supply of fresh water. In the 1st century AD, almost 180 million gallons of water poured into Rome daily. These aqueducts are another example of an arch and dome system. Ancient roadways were used by the Persians and the Romans for strategic and commercial purposes. Greeks needed to have roads available in the event of a religious exodus. The roads typically had a width of 8 or 9 feet and a depth of 3 or 4 inches. Sometimes it was increased to 12 inches to make the road smoother on rocky ground. Romans were generally believed to be masters of road engineering. At the height of their power, they had constructed 50,000 miles of paved roads. No other comparable road system existed outside of the Roman Empire. The earliest known Roman bridge, the Pons Sulpicius in Rome, was made of wood and was constructed using columns and beams. The pile foundation was created by following specific steps: excavate, clear, and then drive previous charred olive or oak piles into the ground as close to each other as possible. The spaces were filled with ash, and this is an example of a timber bridge. Most ancient Roman bridges used the arch as a basic structure, and were typically made of stone and concrete. So this one is a bridge across the Afrin River, which is now Syria, northern Syria, and it's still used today. And then this is a Roman bridge in the south of France. The first cast iron bridge ever built over the Cervine in 1779. A new blast furnace nearby lowered the cost and encouraged local engineers and architects to use iron to cross the river. The use of iron allowed for longer spans and lighter structures. Structural steel. The Eiffel Tower is one of the last iron structures, marked by the end of the Iron Era. In the 1890s, steel replaced iron as a material of choice for large construction projects. Although it contains iron, steel also contains carbon, which is a material that makes it harder and tougher. In addition, steel is less susceptible to corrosion. Steel frames were designed to carry the building loads so that the massive load-bearing walls were no longer necessary. As this happened, the heights of the buildings grew. So this is the Empire State Building in New York, built with steel. The concrete mixture used by the Romans was very weak in tension, so that's stretching and bending. Experiments with improving the tensile strength of concrete by embedding metal rods into the mixture began in the 1800s. Eventually, engineers learned how to do it efficiently so that they could make bigger buildings that could withstand more tension and more bending. Since that time, reinforced concrete has been used for a variety of construction projects. So this is an example of a building in the Arab Emirates. It's the tallest man-made building, and it's used by using reinforced concrete. Engineers quickly understood that reinforced concrete could be used in the design and construction of bridges. The first reinforced concrete bridge was built in France in 1907.